Hello, this is Lindsay Drangeid, and I would like to share a little bit about my plans for my own personal passion project as an example for what I could have students do. I'm looking at transistors in circuits. So I'm first going to talk just a little bit about how they work and how they're used in electronics, give a very brief history of the invention of the device, talk a little bit, just show a little bit about the precursor to the transistor called a radio tube, and then briefly talk about why I'm interested in doing this. Transistors are used in pretty much any circuit. Any electronic device has got multiple transistors in them. They're used to regulate current, to amplify signals, and to be used in conjunction with resistors, capacitors, inductors, diodes, amongst other sorts of things. I'm looking at them when they're used as a switch, as in an on-off switch. I'm looking at just really that basic function, turning something on, turning something off. What I'm going to be putting together doesn't really have any useful application. It's just exploring how they work. Anytime you've gone and turned a light switch on the wall, you know that that switch controls the light. And most people understand that it either allows current to pass through the light or it doesn't. It's essentially connecting a wire inside of the wall behind the light switch. The benefit of a transistor, it doesn't require a human to be physically turning something on and off. It can be controlled by a computer, by some other electronic device, by a sensor. And that allows it to be used in a bunch of different applications. It also allows it to be automated. So you don't have, and it allows it to be faster since you're not relying on a person to switch it up and down. The idea is that you have current that wants to pass through the resistor, but there's a material that doesn't allow it to pass. And by applying a small voltage to that material, it lets current pass through the resistor and pass through whatever else you're trying to power. Every transistor has three basic parts called an emitter, a collector, and a base. The base is what you apply voltage to actually allow the whole device to work. Maybe not surprisingly, the emitter is where current is emitted from it. The collector is where current is being fed into the transistor. These are just a couple of diagrams showing how you connect power supplies to a transistor and a simple device like a light bulb. I'm using sort of a combination of these two diagrams. In the top diagram, it shows a battery, and the bottom, it shows a battery and a controllable power supply that allows direct current to pass through the circuit. So I'm going to be using a direct current power supply to both power the light bulb and to power the transistor. So I'm just exploring a little bit about how much voltage is required to make it all work. In the future, I would have two power sources, but I'm keeping it simple for now. With the transistor I've bought, it can handle the amount of current that's going to be fed into it by the power supply with any strange interventions. I will say that in experimenting with it, I first hooked it up wrong, which sends current the wrong way through it, and it got hot in a big hurry. I won't do that again. There are two types of construction of a transistor. One is called NPN, the other called PNP. It stands for negative, positive, negative, and positive, negative, positive. It refers to the materials that are actually inside the transistor. So looking a little closer at this device that has got these three pins sticking out, the emitter, base, and collector, the specific transistor I've bought has that first pin being the base. That's the controlling pin. The second pin being the collector, that's where current is fed in to try to power something. And then the third pin is the emitter, where useful current comes out and powers your circuit. The specific type I'm using has a construction that's called a Darlington configuration, named after the person who invented it. And those are the three pins again. Not all transistors have the same pins, serve the same function. Sometimes the middle pin, pin 2, is the base pin. That's actually a little bit more common. So you got to make sure you know which are which for the one you've purchased. So this happens to be an NPN, negative, positive, negative type of transistor. A good description of how a transistor works is actually to use water as an analogy for current flowing. So if you don't have a transistor, if it's just a wire, it's like an open pipe that just lets water flow. Once you put the transistor in, pardon me, it's like putting something in the way of that pipe that just won't allow water to flow. It's a disc that can slide in and out in this diagram. So that disc ends up being connected to a little swingable gate by a pulley. And then there's a second little water pipe that actually pushes on that swing gate. So if the water going through the small pipe at the bottom has enough pressure behind it, voltage is oftentimes given the analogy of water pressure, it will push the gate open, that will pull on the string, that'll pull the disc out of the way, and it will start to let water flow through the main pipe. If there isn't enough water flowing, not enough water pressure, voltage, it just won't push open the gate. It hasn't reached a certain minimum threshold, and so that won't be enough to pull the disc out of the way, out of the main pipe. Nothing will happen. Once you've reached this minimum value, it will push the gate open a little bit. Again, the gate has some resistance to it, so it just doesn't fly open. The more water you have pushing against it, the more pressure, more voltage in the case of electricity, the farther it pushes the gate open, and the more that it pulls the disc out and allows water to flow through the main pipe. So this is the analogy given to an electronic transistor. So the input current gets connected to that middle pin, the collector. Inside of the material is, inside of the transistor is a material that doesn't easily let current flow. It's a semiconductor. And that actually, the NPN designation refers to the type of semiconductors you have. And so current is trying to flow from that middle pin to the right pin, but this material is getting in the way. It's not allowing. Then current is passed from the base, and inside of that black plastic housing, the base is connected to the emitter, the output of the whole thing. And if that little bit of current is passed into the base, it actually pushes some electrons out of that semiconducting material. Well, it leaves back behind a gap that can be filled by electrons coming from the collector, your main power source. And then if there's a gap, those will start to flow out of the excuse me, out of the emitter through the circuit. Um, and once there's enough current passing from the base to the emitter, that has pushed all the electrons it can out of the way, so it maximizes the open gaps that can be filled by the main current passing in through the collector. So you can modify the amount of current through the main circuit with a small amount of current through the base. That's one use for this, is that you can take a very small input signal from the base and then have a much larger amount of current passing through the collector. And that's how it's used as an amplifier. So you have a small signal sent from, like, say, an electric guitar, and then that signal varies how much current gets pushed in through the base, and then there's all this current waiting to pass from the collector to the emitter. So that's another use for transistors. And there was no transistor in it. So I was just playing around with initial power settings on the top, and then once I had everything actually going and turned it on, that was a power setting on the bottom. So again, in this diagram, there is no transistor in it. It's just testing to see that all the components work. Okay, that breadboard, that's a common device used for prototyping circuits. Been around for a long time. It will be used forever, probably. Little closer up image. That red wire you can see on the left, that is not, since it's disconnected, it doesn't allow current to pass from the red clamp on the top into the base pin, and that little red light does not light up. When I've got that larger red wire connected to the base pin, then that allows main current to go from the collector to the emitter and out to that red pin, and then out of the circuit again through that black clamp. So it worked. And then the other two lights, the red, the white and the green, I just put in for fun. Little close-up, much closer picture of what I did. On the left, again, that larger red wire is not connected. And on the right, it is connected to that base, the controlling part of the transistor. So not connected, no light; connected, light. Not really going to get into any of the function of it, but just a passing comment on valve or radio tube amplifiers, which were what were used before transistors. They got warm, they required a while to warm up, they could break easily, but they did their job. But then the transistor came along, and transistor came along in 1947, and everything sped up, everything got compact, became far more durable and much faster, and it could be used for more things. And those are the three who invented the transistor in 1947. This is the schematic they drew up, and that's the first one they actually built. They don't look like that anymore. And this is more of a broad overview of everything that happened from invention to essentially modern day. So finally, why I'm doing this. I do teach circuits, but because of time constraints and the requirements of curriculum, I've never dealt with transistors. I knew their basic function, but I didn't know how they worked, and I just wanted to understand how they worked. I've put this slideshow together in a way that I'm hoping I could possibly use with students for fun when we have some time after, let's say, the AP exam. So that's maybe not exactly the format that was required, and this is running a little long, and I apologize. But I had to seize the opportunity to also create something that I could use in the future, so I apologize. What I've built really would be useless for any practical task. I just wanted to see how to actually connect a transistor, and now that I see how it functions, how to connect it, then I can start diving more deeply into applications that are more real world. But it'll be fun. It'll be largely on my own. I own all the equipment, so it's just be at home. I can have it around and just putter with it as I see fit. I'm hoping to even be able to put together a little workshop for myself where I can just leave things out. Here are my references. And I just wanted to dedicate this to my mom, who left us not that long ago. Matter of fact, yesterday was her funeral, so she was always supportive of me. Thanks for a good class, and good night.